Good morning, everybody. Good to see you all. Lovely to be here in Rome. Just want to quickly say thank you very much to Gabriele and all the other organisers for inviting me here. This is my first visit to Rome. I'm really looking forward to having an opportunity to have a few days wandering around the city after Scala-Italy is finished. But there's a lot to happen before that. Looks like this is going to be a wonderful day for everyone. I hope everyone gets a huge amount out of it. So thanks also for the introduction. I'm Miles Sabin. Amongst other things, I'm one of the co-founders, along with Lars Huppel and Eric Osheim of Typelevel. I'm also a partner in the UK consultancy Underscore, along with my colleague Dave Gunnell, who's here somewhere at the back. And as most of you probably know, I've spent quite a lot of the last few years wrestling with the Scala type system in and around Shapeless, and then most recently the Typelevel fork of the Scala compiler, which we will talk about in a little bit. What I wanted to do today is just say a little bit to start with about what is Typelevel, what's it about, what's it for. Before I do, can I have a quick show of hands? How many of you already have heard of Typelevel and know what we are and what we do and everything? It's kind of, I would say about 3/4, something like that. That's pretty good. But you know, that still means that there's lots of people who need to know who we are and what we're about. So we've got a really nice kind of one sentence summary. I kind of owe this, I think, to kind of Eric Osheim from a talk he did at Scala World a couple of years ago. What we're trying to do is remove the barriers, be they technical or be they social or community, to people making a success of doing functional programming in Scala. That's really what we're about. That's what our aim is. That's what we're trying to do. Given that that's what we're trying to do, Typelevel is, well, it's a community. It's a community of projects, and it's a community of people, which are organized around technically pure functional programming. We are definitely functional programmers. State should be managed, controlled, referential transparency, purity, these are all very important things. We're also keen to explore functional programming in idiomatic Scala. There is a huge amount that we can all learn from other programming languages, other programming language communities. Haskell is obviously a very, very important influence on a lot of the things that we do. But other things as well. We're interested in things that are moving a little bit beyond where Haskell has taken us to, languages like Agda or Idris, or some of the interesting proof assistant like things like Coq or Lean and tools like these. And we're very much trying to kind of push ahead with really the things that are Scala's strengths, rather than trying to sort of slavishly imitate things that we might find in other places, but nevertheless trying to take as much inspiration from those as we can. Scala is a very rich and powerful programming language with a very expressive type system, and it's you know, we should take it for what it is. And we should try and make as much use of those facilities as we can. That's from a technical point of view, but also there's more of an aspect of it's not just about the technology. We also have to want to share ideas. We have to want to share code, and we have to convey these ideas. It's not just enough to be sort of sitting in a corner working on an interesting puzzle. We want to be able to express that, share that with people. We want to share our excitement and interest in the sort of the techniques and paradigms of functional programming with types with as many people as possible. To do that, we need to provide learning resources, documentation, which are accessible to people, that people can read, that people can approach, that they can find. It has to exist in the first place. I've been one of the worst offenders with this as far as Shapeless is concerned for a very long time. My colleague Dave at the back has done me and everybody else a huge favor by writing a fantastic introductory book on Shapeless, which is picking up on that. But at the very least, we need to recognize that those kinds of efforts are important things. They're not an optional extra. They're something that we have to do. We've got a bunch of people who are involved in Typelevel who are very keen to do that, and also to build tools that help make that possible. Rob Norris's wonderful TUT, sort of type-checked documentation generator is an absolutely wonderful thing, and there are other things in that kind of general area, and also just sort of templates and patterns, and the idea that projects can sort of set an example. I think CATS has been doing a really pretty good job of showing the kinds of things that have to be done to kind of make this stuff work. We also want to be a friendly bunch of people. We want people to be able to come and participate in all of the community activities, the online presences that Typelevel have. Wherever they come from, whatever their level of experience, whoever they are, and feel welcomed and feel that they can have a positive experience, learn something, take something useful away from their involvement with Typelevel in all its manifestations, and that's a very important thing. The final thing is perhaps not quite so much to the fore. I think those are the main, most important things. But we do, as a general rule, have a pretty strong commitment to independent, free Libre, open source software. Pretty much, all of the Typelevel projects are open source software. And none of the projects have any large corporate sponsors. So you should definitely view Typelevel as being a kind of grassroots, bottom-up, community-driven entity. There is no sponsoring corporate entity. We are very much a volunteer and community kind of grassroots effort right the way through. Might actually be easier if I just did that. Yes. If you want to find more, head over to typelevel.org. You can find the main sort of discussion channels. Pretty much everything in Typelevel has switched over to using Gitter as a replacement for IRC channels and things like that, or mailing lists. There is a Typelevel general Gitter channel, which is sort of general Typelevel discussion. Most of our kind of general organizational stuff, it's completely transparent, it's completely in the open, it's available for anybody to see what we've been talking about and discussing. And we operate, really, because all of our projects exist on GitHub, by and large, that we operate from out of GitHub issues. So if you want to find out what is going on, what is the status of, say, the membership of a given project in Typelevel, the place to go is the GitHub Typelevel general projects, where you'll find various documents and issues which are to do with managing the project as a whole. So that's where to find information out about us. So anyway, like I said, it's a community of projects, and my goodness, what a lot of projects there are now. I've given variations of this talk sort of over the last, sort of since the beginning of last year, I guess, and the list of projects which are, this is the list of current full Typelevel member projects. I would guess that, is there anybody in the room who hasn't used at least one of the ones on the list? Show of hands. For the record, only one hand went up in the entire room. So it's a pretty impressive list, I think, now of projects which are really quite key parts of the Scala ecosystem. I'm extraordinary. I was chatting with Lars about this. I mean, Lars, it was really him that initiated it a very short, surprisingly short number of years ago. I think 3 maybe. And at that stage, the 3 founding projects were Scala-Z, when Lars was the maintainer of Scala-Z. Shapeless and Spire. And I don't think although we thought it was an important initiative, I think we were not really expecting to have quite such an extraordinary success of attracting people to the general ideas that we were trying to convey. So I think we're remarkably pleased. But these are just the full members. There's a huge and growing list of, well, growing and also shrinking list of projects which exist in the Typelevel incubator. So there is a sort of we have a fairly permissive set of criteria for what kinds of projects we believe are appropriate to be full members of the Typelevel roster of projects. Some of them are technical, some of them relate to sort of community aspects. But we also recognize that, for example, not all projects can immediately claim to be, if you like, fully in the spirit of pure functional programming. So there are a number of projects which are, if you like, on the path to getting there, and we want to make a space for those kinds of projects so that we can help and assist projects develop in the kind of direction that we think is best. There are also projects where we have various kinds of very rough and ready criteria about we want projects to be able to commit to being able to make consistent releases and things along those lines, which again in the early stages of a project is not necessarily possible. So we have this sort of incubator phase before full membership. So this is both a growing list and sort of new projects arriving. I think one of the most interesting recent arrivals is at the top left there, Cat's Effect. I don't know how many people have run across this before. This is a project started by Daniel Spiewak and who else? Who the other? Well, Daniel announced it anyway. I forget who the other maintainers are. So cats, I think there must be at least one talk probably on cats today. I'm not. Yes, I think Daniela is doing a talk on cats today. So cats is really a library of fundamental abstractions for functional programming. One of the things that has been somewhat holding back people from adopting it has been the lack, until Cat's Effect comes along, of a completely immediate and compelling story about how to deal with effects, so some kind of task or I/O type. This is something which is now happening under the Cat's Effect banner. And I think once that's available, and once the Cats 1.0 release, which is hopefully going to be, we'll have at least a milestone of the Cats 1.0 in time for Scala Days in Copenhagen and the Typelevel Summit in Copenhagen. So we're very much hoping for that to be the case. Once we have a Cats 1.0 and Cat's Effect giving us a good story on effects in a functional setting, then I think we will see an awful lot of adoption of cats in many contexts where people have been a little bit reluctant to jump for it straight away, which I think is very encouraging. We've seen some recent announcements. There's several, I think, very important libraries have made a commitment to move to cats. So HTTP for S, Doobie. I think there's at least a couple of others who've decided to switch from Scala Z to cats, and I think again the cats effect stuff is going to help with that. I think FS2, although it's not a Typelevel project, is also likely to depend on cats effect and the cats core, the core fundamental abstractions. Okay, so there's lots happening. We want more. So I mean, if anyone is working on open source projects which they think sort of fit in with the sort of general spirit of what Typelevel's trying to achieve, please do. We really do encourage people to come and come and join us. It's definitely what we want. Okay, Typelevel Scala is another project that's been on ongoing for quite some time. I'm going to come back to that in a bit, because I'll talk about that in a bit more detail, because that's what I've been working on. So as well as community projects, Typelevel is also a community of projects and people. So up until the beginning of last year, Typelevel was primarily a sort of an online, essentially just a collection of open source projects. At the beginning of last year, we decided that we really needed to start having actual sort of physical meetups, conferences dedicated to sort of collaboration between the projects. This is one of the key things that I think we've been able to achieve is actually having. In fact, I think we can kind of see that if we go back to the list of projects and incubator projects. You'll find many of these projects will have some kind of interaction between one another. So, for example. Well, I guess everything which has less as a suffix has probably got some kind of shapeless dependency lurking in there somewhere. But there's also a number of projects which depend on cats in some way or another. Monocle, the lens library, that is used in several different projects. So Circe, for example, makes use of provides various kinds of lenses drawn from Monocle. We have, there are various other projects which depend on Refined. So Refined is a project which kind of builds on Shapeless, but also does quite a lot of its own stuff to provide to provide very precise refined types, sort of dependent, sort of moving in the direction of the kinds of dependent typing that you'd expect to see in languages like Idris, and that contributes a lot to a variety of projects which are able to specify very precise compile time checkable predicates. So again, there are Circe modules which relate to Refined. So there are lots and lots of interactions between the projects, and this is something that we've been wanting to encourage as much as possible. And having meetups, summits, conferences, workshops, these all contribute to us being able to do that. So we had the first one in Philadelphia with Any Scala, the Northeast Scala Symposium last year. Then we had a summit in Oslo alongside FlatMap. This year we've sort of moved everything around. So Any Scala moved to New York this year, so we went to New York. Copenhagen summit is this year's it's going to be co-located with Scala Days, obviously, in Copenhagen, and we're hoping to see lots of people here. So there's a bunch of things that have been going on in London. We have Salesforce very kindly provide a wonderful space with an amazing view over the city, which free of charge, which has allowed us to do an awful lot of work in London, which is marvelous. And we have a bunch of upcoming things. So the next summit is the Typelevel Summit in Copenhagen. Please come. Anyone who's going to Scala Days, it's a no-brainer that you should stay on for the one extra day and come to the Typelevel Summit there. There's going to be another Scala World Typelevel workshop of some sort to be decided. If John Pretty's in the room, he is. I expect that the exact format for the workshop will be decided the day before the workshop, if previous experience with Scala World is anything to go by. But I can guarantee that whatever happens, it will be awesome. There is very likely to be a Typelevel workshop at Lambda World in Cadiz in October. And also we've fairly regularly done some form of workshop / hack day following Scala Exchange in London. So at least these things, please, if you're in the area, or if you want to make a trip for it, then please do. We'd love to see you there. And also we want more. So I think it would be great if maybe scala-italy next year had a Typelevel workshop of some sort attached to it. That would be a great thing. Maybe. Okay, so that's what Typelevel is. What about Typelevel Scala? So this is what I've been working on for the last, I guess, how long have I been working on it now? I suppose I've been spending quite a lot of my time on it for about the last year. And I think we're beginning to see some quite interesting results. So what is it? So it's a fork of Scala. We kicked it off at the end of 2014. So this is going back a bit. And the aim was to try and I think if people kind of put their minds back to where Scala was in 2014, I think there was kind of a bit of a lull. I think it sort of felt a little bit like sort of the pace of development of Scala as a language had sort of dropped off, tapered off to a certain extent. Dotty at that point didn't exist, and I think it really did feel as though things were perhaps not moving along as quickly as they might be. And it was certainly true, and it felt within the sort of the Typelevel umbrella of projects, as though there were an awful lot of issues that we had, which were maybe not high enough priority for the TypeSafe, as it was then, the main maintainers of the Scala compiler and libraries. It was not at the top of their list of priorities, and we kind of felt that that's fine, it's that TypeSafe stroke Lightbend. They are absolutely entitled to set their priorities for themselves, but we needed to do something about this, and the best way to address that was by actually trying to address some of the issues of ourselves, and so it was particularly of interest to us to try and deal with the very specific kinds of problems that people have hit when working on using types in the way that is fairly typical in type-level projects. So at the time, in say, Scala-Z, or Shapeless, or Spire, or whatever. The whole project stalled at the beginning of 2015, and it stalled around the time of the kerfuffle around Scala-Z that people probably remember. At that point, we kicked off CATS, and I think pretty much everybody who had previously been involved in working on the type-level Scala was at that point so preoccupied with working on CATS that we really didn't have any bandwidth or resources to do anything very much about it. So it kind of stalled then. And also, I think over the course of the 2015, we kind of we found an awful lot more interesting and sort of vaguely usable sort of workarounds for the kinds of problems that we were having. So we basically patched things over in sort of increasingly in ways that kind of worked. So although an example of that would be, for example, Eric Ostheim's kind projector. So a kind projector allows you to express type level, a particular kind of type level function in a fairly syntactically succinct way. Certainly more comprehensible than the infamous type lambda Scala idiom. So ideally we would incorporate that kind of syntax directly into the language, but okay, we can get by with a compiler plugin that will do something a very, very good approximation to that. So we got around various issues with plugins and various macros of one sort or another. But for all that this helped, there are still some fairly fundamental problems that honestly just couldn't really be resolved. So one example of which, and it's still an open issue, but it's one I hope to spend some time on later this year, is implicit prioritization. So prioritization of type class instances in particular. When you have a type class, your instances have to come from somewhere, and there can often be competing candidates, which it's important to be able to, rather than just have them generate ambiguities, to be able to specify some kind of priority ordering so that the precise implicit instance that you want, type class instance you want, is the one that's selected. It is enormously difficult to Scala has very, very subtle rules for specifying how that works, and they often work against the way that you might actually want them to work. So it's a very, very delicate balance, and most approaches to this basically don't work. I attempted to address this in a library of mine called Export Hook, which kind of does the right thing, but it does so in a way which brings quite severe compile time costs in its wake, and is also fragile in various ways. So it's really not a very satisfactory solution. And I guess at that point I kind of realized that really this isn't good enough. I mean, the only way we're actually going to solve this problem, these kinds of problems properly, is if we actually start investigating doing work on them again in the compiler in some way or another. Okay, so I kind of set myself a goal at the beginning of last year. To see, actually, can we do this? We thought we were going to have we took a swing at it in 2014 initially to see if we could fork the compiler and somehow or other make that work. It never really gelled, and so at the beginning of last year, I thought it was time to give it another try and see if we could come up with something viable. So, and if it's going to work, it would be good to pick something that would actually demonstrate some actual real value. SI2712, for people who know what it is, it's a big deal. For people who don't know what it is, you don't need to worry about it anymore, as we will see shortly. So I thought I'd take a swing at it. It's been a very, very long-standing Scala compiler bug, going back years and years and years. 2712. It's not a 3-digit ticket number, but it's an early 4-digit ticket number. So that means it's been around since I think 2007, 2008. I can't remember, but anyway, a long time. It turned out, sort of initially I thought I was just going to spend a little while on just hacking something together that just to see how it might work out. But it turned out that basically I managed to get a fix together in a matter of days. I mean, less than a week or so, and the net result was, with a lot of help from Jason Zaug, but nevertheless, within a relatively short period of time, we ended up with a full fix for this bug, merged in the Scala compiler, in the mainline Lightbend Scala compiler. And I think at this point, a lot of us were sort of woke up, sort of blinking, sort of, well, what just happened there? It was very surprising in a way that we'd had this apparently intractable problem that for years everyone had been saying, we can't fix it, it can't be done. We'd had various people. Paul Phillips is wonderful, has made enormous contributions to Scala, but one of his less positive contributions has been his characterization of the internals of the Scala compiler as basically a tire fire. Are not completely inaccurate, and I can absolutely understand where he's coming from, but they're not encouraging when it comes to getting people to sort of roll up their sleeves and dig into helping out with a project. You need to feel, if you're going to start working on an open source project, that it's possible, that you're actually going to be able to make some progress, that you're actually going to be able to get some results. And I think what had happened is that all of us, absolutely all the way through the community, that's from sort of long-standing, long-standing members of the community to more recent arrivals, so just assumed that the Scala compiler internals were just too hard, too inaccessible. There's nothing we can do. It all needs to be rewritten from scratch. It can't be done. And I think that my discovery was that actually it's really not that difficult. And I've quipped a few times that I don't have any superpowers, Scala superpowers. But even if I did, I wouldn't have needed them to fix that particular bug. It was actually pretty simple, and I reckon that if most people in this room sat down with a bit of clear time, they could probably have fixed the bug too, or at least a lot of people sitting in this room, I'm sure, could do it. And I think this opens up a whole world of interesting new possibilities about how we might be able to evolve the language ourselves in the direction that we want, in the direction that fits the kind of things that we work with. So sort of encouraged by this, last year at Scala Days Berlin, so I guess that's about a year ago now, I kind of set this sort of agenda for things that I wanted to try and take a look at between now and the end of 2016. So the top bullet, 42.type, that's something that had actually been done largely by George Leontief and with some help from Adrian Moores quite some time before, and was part of the original Typelevel Scala compiler fork. So one of the things I wanted to do was, well, let's revive it. So 42, this is the language extension which allows us to have very concise syntax for singleton types for values. So for example, a type of, we have the type string, which is inhabited by all strings, but there is also the type hello world, which is the type which is inhabited by just that one string, quotes hello world. Sounds somewhat obscure, but there are actually a whole load of very, very interesting uses for types like these. In shapeless records, for instance, is one possible application for those things, but there are many others. So it's by no means an esoteric kind of thing. As anybody who's ever used shapeless for a non-trivial project knows, it can have a rather detrimental effect on your compile times. There is, my apologies, I am trying to fix the problem. So one of the things that's I mean, there are some very, very regular patterns in the way that shapeless's type class materialization works, and it's sort of it's an inductive pattern. Typically, an instance for operating on on an H-list, which is, say, a representation of a case class, is to have sort of a pair of type class instances, one as a sort of a base case and one for a step. So we've got one thing we do when we hit the end of the list, and one thing to peel an element off the head of the list. But the key thing is that there is an inductive pattern which sort of unfolds across the structure of a type. This plays out really nicely with Scala's implicits. It's one of the I think most interesting features of Scala's type system, I think that it really is a remarkably powerful mechanism for doing useful forms of computation at compile time. But the Scala compilers internals were just never designed with that in mind. I mean, it falls naturally out of the semantics of implicits that you can do this, but the internals were not written optimally to handle those kinds of cases. So it felt like, well, if we have a look at it, it's possible perhaps we can come up with some kind of mechanism which will actually handle those cases in a rather more optimal way. So that was something I wanted to have a look at. Core Scala was an interesting thing. So obviously, as I'm sure most people know, there's quite a lot of controversy about what should be in the Scala standard library and what shouldn't. One of the things that sort of dropped out of that was an idea that maybe there ought to be a very small core of the Scala language and a core standard library, which basically is just a language support library. So, for example, which would allow you to swap out the existing collections with, say, an alternative collection implementation or something along those lines, and just restrict the Scala library to just the absolute minimum which is required to support basic language constructs. So, for example, say the semantics of pattern matching require option. So you would have to have option as a minimum, but you wouldn't necessarily have to have vector as part of the standard library. And there's a bunch of other things. So implicit prioritization, I mentioned that earlier, and various other things which are relevant to different amongst the Typelevel projects, but things which would otherwise require clunky workarounds, various kinds of encodings of one sort or another. Most of these things can be represented in one way or another in existing Scala, but it's just awkward, and it makes things which should be quite simple and easy to read actually quite complex. And I'll show an example of that a bit later on when I show some of the recent work. So these were the things that I kind of thought we ought to start taking a look at. And it turned out that we could do an awful lot of this stuff. So this is the current status. So the literal type stuff, that's been around for a while now. I've done some work that I've reported on kind of over the last 6 months or so on improving compile times for inductive implicits. There's still some work to be done to actually make this provide the full compile time improvements that I've been promising for Shapeless. But a big chunk of that has been done. There's a bit more, which actually, interestingly, has been prototyped for me by Martin in Dossi. I'll come back to that in a second. Core Scala, we've kind of angled at that in a different way. It turns out that there's actually been an awful lot of work being done both by Lightbend and the Scala Center as well on the new collections framework, more modularization of the Scala standard libraries. So in a way, I think everybody's kind of agreed that some notion of a core Scala is a good thing, and there's lots and lots of activity happening outside of type-level Scala around that, which I think is all good stuff. What we do have, though, is that Andy Scott has contributed. This is a pull request against the mainline Scala compiler, but it's also part of type-level Scala. It's a mechanism which allows you to alter what predef is. So there are various things which are by default made available without import in a Scala program. So it's the contents of predef, the contents of the Scala namespace, and actually I think by default the contents of the Java Lang namespace. I actually forget which, but anyway, there are various things which are up until now have been available as, if you like, a hard-coded list of things which are effectively automatically imported in every Scala program. This is a mixed blessing. On the one hand, it means that various things that are useful are available without any ceremony. On the other hand, there are various things of dubious merit which are foisted on you, and you have no real option of getting rid of them. Getting rid of any to string add, for example, is an absolutely ghastly thing, which should have never been in predef, but is automatically imported, and it's very difficult to get rid of it. So being able to specify an alternative predef and alternative system definitions, I suppose, is the Scala namespace is one way you could view those. Would be very useful, and Andy Scott has done some initial work on that. The pull request hasn't been merged yet. It's on the list of candidates for being merged in a later mainline Scala release, but it's available now in type-level Scala. The multiple implicit parameter blocks, that also, I did some work on that. It turned out to be surprisingly easy to get a very, very simple version of that up and running. In the end, after having some discussions with Adrian Moores, I decided to try something a bit more ambitious. So that's on hold for the moment, but I will come back to it at some point. And it will interact with partial type application. Implicit prioritization is, again, that's coming later. Okay, so that's where we've got to. So if you're thinking, that all sounds great, but how is that relevant? This is this crazy fork of the Scala compiler. Can I actually? Why? Am I going to be able to use that? Can I use it in my work projects without getting fired, basically? And also, does it mean I have to sort of clone a GitHub repo and build something? Can I just use it now, or do I have to wait for these things to be merged by Lightbend? So I think the answer is that to be able to do this stuff compatibly with people keeping their jobs, we need to be actually quite conservative in a way. And so basically I've set a number of constraints on what is allowed to go into type-level Scala and the way that it's going to be released. Releases have to be compatible with the existing ecosystem. I mean, this is I think perhaps the biggest issue, and it's the big problem that Dossi I think is going to experience over the next few years, as it attempts to become a later iteration of Scala rather than a distinct language. The existing Scala ecosystem is binary. It's on Maven, and really any project that's going to of any significance is going to have an enormous mass of binary dependencies on existing artifacts, and we can't just abandon those things. I mean, the transition costs are too huge otherwise. So we need to be able to use existing binaries with programs which are compiled with the type-level Scala compiler. To use it now, you've really got to get something out of it. So I mean, I think probably the thing that most people are going to get. aside from things like SI2712 have provided enormous benefits already. They've had some big impacts on say, reworkings of various bits of CATs, which have greatly simplified things. But there's no worry there because that's all been merged in the Lightbend Scala compiler. So for things which are still outstanding, which haven't been merged yet, it's got to be a big win. And I think probably the biggest win is the inductive implicit stuff. I don't know. I can do a demo at the end, but I think probably by now most people have seen it. It can for I don't know, say serializing case classes of, or sort of serializing ADTs, algebraic data types, with quite a significant number of branches of significantly sized case classes. It can produce, reductions in compile times of several orders of magnitude. So it's a big win, and I know that people have switched over to using the type level Scala simply for that, and absolutely nothing else. So that's the kind of benefit that I think is compelling enough that people are prepared to risk something that might otherwise be a little bit risky. And you can't be expected to re-engineer a whole bunch of infrastructure to use it. It's got to be something that you can do easily at low risk. Okay, so the goals are that we're going to track Lightbend Scala releases. Oops. So for each Lightbend Scala release, there should be a corresponding type level Scala release, just adding the incremental features that the type level Scala provides. It should generate code which is binary compatible with the corresponding Lightbend Scala release. And that means that basically, with some caveats, you can cross-link type level Scala binaries with Lightbend Scala binaries and vice versa. And then obviously we want to kind of aggressively push for features to be merged back into Lightbend Scala as soon as possible. The caveats are that obviously where the type level Scala introduces new types, for instance, new concrete types, then clearly if you have a dependency on one of those because you're using one of them, then you have to link against a type level Scala library, Scala library jar. An example of that would be one of the new annotations that's been introduced in type level Scala. But if you don't use it, that's not a problem. Okay, so the rules for anything to get into type level Scala is it's got to be a pull request against Lightbend Scala first. So basically anything that is going to get merged in type level Scala has to be already a candidate for being merged in the mainline Scala compiler. And there's a couple of reasons for that. One of them, obviously, is it means it runs through the Lightbend Scala CI. It means it's set up in a way that it could very straightforwardly be run as a Scala community build job of some sort or another. And also, it means it gets reviewed by Jason Zaug, Adrian Moores, Lucas, et cetera, so we can kind of benefit from their experience, kind of taking a close look at what we've done. It's got to have a reasonable chance of being merged. There's no point sort of delete all, replace with the implementation of the Idris compiler. That might be a pull request, but I think there would be zero possibility of it being merged. It's got to offer something interesting, and for which there's no easy workaround, and the binary compatibility constraints are important. Okay, so the results are, and they have been pretty good, I think. I'm really pleased with what we've got. This is basically after a kind of a year of work. These are all things which appeared first in a type level Scala compiler and have been merged either to Lightbend Scala, to 11.11 or to 12x, or DOTI, interestingly. So the SI2712 fix and the SI7046, those are two things which have been kind of bugbears for people using shapeless for type class derivation. Hopefully, you will never even need to think about these numbers anymore. So the problems that they correspond to just don't exist now, so that's great. The literal type stuff I mentioned before, that's outstanding for Scala. It's still scheduled that maybe sometime in 2.13 it will be merged, possibly probably not 212. However, there are some very, very minor differences in what's in Dotty, but basically it's merged in Dotty effectively. Lazy implicits is interesting. This is the sort of the outstanding bit that I need to work on to fully realize the benefit of the inductive implicits work. So a lot of the inductive implicit stuff is actually related to the lazy type class, the lazy magic type in Shapeless, which is backed by the most horrible, horrendous macro you have ever seen in your lives. Don't go there, honestly, it's a nightmare. But its whole rationale is to allow you to construct recursive implicit values. And that's important because if you're trying to derive a type class instance for a recursive type, you need to, the instance itself is going to embody some recursion somehow. So you need to be able to sort of tie a recursive knot implicitly. Lazy kind of does that in a horrible, clunky kind of way. And it occurred to me that actually by name implicit arguments are not currently supported in Scala. So there's, if you like, some spare syntax. And so I had a chat with Martin about this at Scala.io last year, saying, you know, Martin, I think one thing I'm probably going to try in type-level Scala is seeing if I can reinterpret or provide an interpretation for by-name arguments, implicit arguments in Scala to match the implementation of lazy in Shapeless. And he kind of scratched his head and went away, and a little while later announced, here is a SIP for Dotty, describing lazy implicit arguments. And that, I believe, is now actually implemented in Dotty. So this is great. It saved me the effort of writing a SIP for a language extension because Martin has picked it up and done it. Anyway, but he's beaten me to the implementation. But that's very, very much next on my list. Of things to actually get into type-level Scala. Infix type rendering and trailing commas, they're sort of more aesthetic features, I guess. They're quite useful. They appeared first in a type-level Scala release. They've both been merged in the mainline compiler. So the current release is type-level Scala 4 for 2.12 and 2.11. So basically what we're trying to do is move ahead in lockstep across all of the Scala versions we're trying to support. And then we have a type level sort of feature level, which is going to increment sort of up from 4. It's 4 because this is the 4th Scala type level compiler release that we've made overall. Although that did provoke some mirth on Twitter from Sam. Anyway. Right, so as I said, the version suffix is just the feature increment over the baseline compiler. So the features in release 4, these are available whether you're on 2.11 or 2.12. So you can basically, up to now, it's been sort of dribs and drabs and sort of different between different type-level Scala compiler releases for 2.11.8, 2.12.1, 2.12.0. So now we're just going to move ahead with a consistent set of features across all. So this is, everything else that we've seen before is, and not on this list, has already been merged in a Lightbend mainline Scala compiler. So this is the stuff which we're currently offering over and above. So the inductive implicit stuff, type arguments and patterns, that's a new thing which Paul Phillips contributed very recently. If I've got time, I'll do a quick demo of that. Kind polymorphism, which again, I will do a demo of. The alternative predef, which I've mentioned, literal types, which has been hanging around for ages, but it's still there. And some work that Greg Feil did on improving the pattern matcher exhaustivity analysis, which is very useful for people using GATTs heavily. So that's the current sort of menu. That's what you get for switching to using type-level Scala. So is it risky to use it? I kind of think it's kind of risky not to, because the alternative is to still carry on working with all the clunky workarounds, encodings, and things along those lines. They're full of bugs. They're hard to understand. They generate an awful lot of noise in your code. Typically, the underlying ideas you're trying to express are very simple. But by the time you've worked around the Scala compiler bugs or encoded the features that are missing, you end up with something which is really quite complex and confusing. So I kind of think you actually reduce your level of risk by working with a compiler that actually has them baked in and implemented properly. I think this will definitely be true for the lazy stuff from Shapeless when that's fully implemented in the Scala compiler. It will definitely be less risky to use type-level Scala than to rely on macros. Okay, so how? It's got a little bit more complicated. It used to be, up until this release, you could just change Scala organization to org type level and you were done. Now, because we're adding a suffix, you do have to change the Scala version. There is a reason for that. I mean, the way we'd been doing it before was basically every time there was a Scala compiler release, we would say, right, okay, now is our chance. We have a version number, so we can push out a new type-level Scala release with some new bunch of features. But obviously, that means that we are tied to only ever releasing at exactly the same frequency that Lightbend make Scala compiler releases. Supposedly, there are not going to be any more 2.11 releases, which is a problem if we want to make further releases out along 2.11 with additional type-level Scala features. So we had to have some additional kind of increment that we could add. This is the only mechanism that's really available. The bin bit there, there's some SBT sort of special magic lurking away behind that, which means that SBT will treat that version as being binary compatible with 2.12.2. And there are a few other little restrictions on what you can do, but the modifications necessary to actually use this stuff are not particularly onerous. If you go to the README for type-level Scala at that URL, all the everything you need to know to be able to use type-level Scala in your existing project is there. Okay. Quick demo then. I'm going to do a very quick demo of the kind polymorphism stuff. So this is work by Pascal Voiteau, otherwise known as Mandubian on Twitter and GitHub. So very, very briefly, I just want to show you. So this is just an ordinary vanilla SBT, build SBT, with usual settings. And you'll notice, so these are the settings that we have. So we can switch between using the Lightbend Scala compiler or the type-level Scala compiler just by configuring a different set of settings here. So this would be the Scala organization, this would be the Scala version for Lightbend Scala, and then for type-level Scala, we have org type level as the organization, we have the different Scala version, and then we just add a bunch of Scala C options. So we've got partial unification enabled, that's the SI2712 fix, that's the 42.type, the literal type stuff, so kind polymorphism and the induction heuristics, so they're enabled. But other than that, it's a completely vanilla project, and you'll notice that we have a dependency on Shapeless here. I'm not going to use this in the demo, because we haven't got time for that one, but that's just the ordinary Shapeless binary dependency. That's the one that you use if you use Shapeless that you use now. There's not been specially compiled. It's just an ordinary vanilla upstream binary Scala dependency built with the ordinary vanilla type-level Scala compiler, and that will work quite comfortably with projects built using the type-level Scala compiler. So all of your existing dependencies should be just fine. Okay, so I'm just going to quickly set up a problem, if I can. Page down. Oops. Where am I? Here we go. Right. So this is to motivate kind polymorphism. So this is a toy example. I can promise you that there are a bunch of really, really interesting cases which are somewhat more complex to convey, but where this is a real benefit. So suppose we're trying to put together a kind of a show type class, but we're not showing a value, we want to show some kind of representation of a type. So it's a show type of T is going to give us some kind of rendering of the type. So show type for int is int, show type for string is string, and so on. Okay. So let's try and extend that a bit. So now suppose we want to add show type instances for composite types. So options, list, vectors. Should all be fairly familiar stuff. So to get an instance, we're going to parameterize in terms of the instance of the type parameter, and then construct something around it. But I think probably the immediate thing you see here is that we've got a whole bunch of boilerplates. I mean, this stuff all looks very, very similar. Can we abstract over this somehow? Well, we might try something like this. Let's see, let's just take that away. This is kind of what you want to write, really. So what you want to write is you want to write show type instances for each of the type constructors, so option, list, vector, set, and so on and so forth. And then we want to be able to define just once. So in other words, the type constructors then become on a par with the fully applied types, int and string. And then we want to be able to define an instance which pulls in the show type instance for the type constructor, the show type instance for the type parameter, and put them together. That's kind of what you want to do. It doesn't work, though, and it doesn't work because the kinds here of this type parameter, option, this is a parameterized type. It's a type of kind star arrow star, whereas this is a fully applied type, a type of kind star. And the Scala compiler simply will not allow us to instantiate this type parameter t to both of those simultaneously. And there is literally no way to work around this at all. There is no place in Scala where you can put both a fully applied type of kind star and a type of kind star arrow star in the same place and have it have it semantically correct. There is nothing. So there aren't even really any encodings available, which aren't horribly, horribly complicated. So the idea we had, and which Pascal has I should emphasize this is fairly experimental stuff, but it does work, and it definitely shows. It gives us enough to sort of experiment with, just how much of kind polymorphism we need as a feature. Basically allows us to specify that a type parameter can be allowed to be instantiated at any kind, and to see how far we get with that. So I'm just going to show two more files, and then I'm done. So this is before I do that. So this is the actual workaround you come up with, and there's a whole load of code around in Shapeless as well, which exemplifies this. So you end up introducing show type 1 for type constructors, and so on and so on and so on. And you end up just duplicating a whole bunch of stuff. There's a whole bunch of stuff in Shapeless, so there's generic, and there's generic 1 for types with one type hole in it. So this is the kind of duplication we're trying to avoid. And last, I'm about to be dragged off stage, as usual. Last thing is, here we go. So this is what we can do now with kind polymorphism, the kind polymorphism extension enable. So this is available now in 2.11.11 type level 4 or 2.12.2 type level 4. So you can put a bound of any kind on a type constructor. And now we can write what we wanted to write originally, which is show type instantiated a type constructor, and then we pull the things together. This now works. This is great stuff. This is going to be one of the things I'm going to be doing for my talk in Scala Days at Copenhagen, is trying to say, okay, now we've got this new stuff in type level Scala. Suppose I were to go all out and try and use all of these features to sort of simplify things in Shapeless, what would Shapeless start to look like? There's a whole bunch of things that this will simplify, and my plan is to spend the next, between now and Scala Days, coming up with some really compelling examples of how this is going to eliminate huge amounts of boilerplate and complexity in Shapeless and libraries like it. Anyway, so that's current work. The roadmap, last slide is this. This is the roadmap. So lazy implicits I've mentioned. Implicit prioritization is very high on the list. And those are the main things, I guess. Those top two are actually the ones that are going to get dealt with first. And that's it. That's my lot. Thank you very much.